Part 2A4C3M1B7C8E13C9C6D3P38D19D7b16b. This is line 22f1fa19c3m1b7c8E13c9c6D3P38D19D7b16b. X-ray photoemission Ois Spectra Part 1B, 5G Wow Seti. This is the second video for Part 1, so you want to backtrack and go to the previous video before this one. Just look at whatever it's connected to as a video response, and you'll be able to find it that way. Okay, so there's the alien radio signal. This is from March 15th, and April 21st was when I was doing some data. Actually, this one says May 4th, 2013. So the X-ray photoemission Ois Spectra plus XPS system plus communication signals for a UFO spaceship from the WOW data. This is basically keyword research. So there's the line of data there. X-ray photoemission Ois Spectra Part 1A was the last video we looked at. 5G Wow Seti. And then we did the keyword X-ray photoemission Ois Spectra. Okay, so this is a photo-emitted electrons picture, basic components of a monochromatic XPS system. It says electron energy analyzer, electron detector, Sigma 2p XPS signals from a silicon wafer. Samples are usually solid because XPS requires ultra-high vacuum, and as some sort of focused beam of X-rays bounces that way, electrons go that way, and this is the electron collector lens there. Okay, very interesting. So here's binding energy and counts. It talks about peak, ID, atomic, and BEEV. That's fine. Wide scan survey spectrum from all elements is labeled BEEV, FWHM, binding energy EV. Then we have the high resolution spectrum for SI2P signals. So it's XPS equals X-ray, photon, electron spectroscopy, X-rays in, electrons out, inside vacuum, aluminum, X-rays, photons, energy. So we're talking about photon energy with the UFO spaceship. So this data is going to be used for something. XPS survey spectra of pure copper, and we do use copper alloys in with the nodes and the microwires to send signals to each other. So this is X-rays excite atoms, electrons jump out, top 20 atomic layers there, usual analysis areas and depth. Looks like the solar system. Okay, so that's a rough schematic of XPS physics, photoelectric effect. XPS is routinely used to analyze inorganic compounds, metal alloys, and we're talking about metal alloys and bendable metals for the exterior of the spaceship. And this is, and it's also going to be used to create signals within the spaceship for long distance communications. So metal alloys, semiconductors, polymers, elements, catalysts, glasses, ceramics, paints, papers, inks, woods, plant parts, makeup, teeth, bones, medical implants, biomaterials, viscous oils, glues, ion modified materials, and many others. So it seems to do a lot of things. XPS is used to measure elemental composition of the surface, top 1 to 10 nm usually, which was shown over here. Empirical formula of pure, it was shown right in this area here. That's where it measures. Okay, so empirical formula of pure materials, elements that contaminate a surface, chemical or electronic state of each element in the surface, uniformity of elemental composition across the top surface or line profiling or mapping. Uniformity of elemental composition as a function of ion beam etching or depth profiling. XPS can be performed using either a commercially built XPS system, a privately built XPS system, or a synchrotron-based light source combined with a custom-designed electron analyzer. Commercial XPS instruments in the year 2005 used either a highly focused 20 to 200 micrometer beam of monochromatic aluminum, Ka X-rays, or a broad 10 to 30 nm beam of non-monochromatic polychromatic magnesium X-rays. A few specially designed XPS instruments can analyze volatile liquids or gases, materials at low or high temperatures, or materials at roughly 1 torr vacuum, but there are relatively few of these types of XPS systems. Because of the energy of an X-ray with particular wavelength is known, the electron binding energy of each of the emitted electrons can be determined by using an equation that is based on the work of Ernest Rutherford, 1914. So E binding equals E photon minus E kinetic plus the zero symbol there, where E binding is the binding energy Be of the electron, E photon is the energy of the X-ray photons. Being used, E kinetic is the kinetic energy of the electron as measured by the instrument, and the zero with the line through it is the work function of the spectrometer, not the material. So the keyword X-ray photoemission spectra will be in the next video. Thanks for watching.